Hey there. Alright, College Algebra, we are going to be hitting 4.5 today. And I'm doing this a little bit different. I'm not going to use the textbook and things. We have these problems here. It's just a few little pieces in 4.5 that we got to go over. However, it's going to take a lot of work. So we'll see how long the video this is. So, two things we're going to be doing today. First is our ultimate goal is finding all the zeros of a polynomial. Okay, and to do that, we're going to use synthetic division to help us. Okay, now the reason we can use synthetic division is when you get a remainder of 0, it's a factor. Okay, and from that factor we get our zeros. Okay, so the easier way to figure out if the number is a solution or a 0 is by running that number through synthetic and seeing if you get a 0 remainder. Okay, so the whole thing is, though, your zeros, and what we're trying to find, okay, is where we're trying to find these locations. Okay, now you could graph it. Now some of these graphs go wild, so you might not be able to find it on your graphic calculator, but we're trying to find those locations. Okay, but if you think about it, your x-axis has a bunch of different options. Okay, there's a lot of numbers that could be possible chances to be answered. This could be -5, it could be -20. I don't know. This could be 4, or it could be 410. We don't know where those zeros are. Okay, and so if we just start randomly trying numbers, we could check forever. Okay. But there is a rule that we can actually find the possible rational zeros. Okay. Now this rule gives us the only possible ones that might actually give me a remainder of 0 that are rational. In other words, they have to be in the form of a over b, which are whole numbers also. Okay. And the term possible is these are things that might work, but they might not work. Okay. The nice thing about this was when we get this list, that list of possible zeros are the only possible rational numbers that can work. And when we say rational, what this does not find, okay, does not find anything that might be irrational, like a radical, root, or any imaginary. Okay, it'll only go find the rational, and they have to be real. Okay, well, to do that, we're going to look at two numbers. We're going to look at the last number, and we're going to look at the first number. And what we're going to do is we're going to find the factors of the last number, okay, and we're going to find the factors of the first number. Now remember, it has to be in order. Whenever you do things, you always want to put things in order and be helpful. So it's the constant over the leading coefficient. Okay, the leading coefficient is the front term. Okay, now when we look at this problem, we're going to find those factors of 18. Now remember, factors of 18 are 1 and 18, 2 and 9, 3 and 6. Factors of 3 are 1 and 3. Okay. So the rule is we're going to take each factor of 18 and put them over the factors of 3. Okay? So now remember, we can't forget the 1. Okay? So if I put each one of these over 1, that's just going to be their whole numbers. So my list of possibles are going to be 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, 18 over 1. Okay? And then we're going to put each of these factors over 3. So we've already done the 1, now we're going to put them all over 3. So that would be 1 over 3, 2 over 3, 3 over 3, 6 over 3, 9 over 3, and 18 over 3. Now, when I want to put my final list, we don't just use those, we also use their plus or minus. So all their positives and all the negatives of that list. Now, to make this a little shorter, we can get rid of any repeats. Okay, well, whole numbers aren't going to repeat. 1/3 is not a repeat, 2/3 is not a repeat, but 3/3 is 1. So we can actually take out 3/3. 6/3 is 2, that's right there, so we can take that one out. That one doesn't need to be written twice. 9/3 is 3. 18/3 is 6, so I can get rid of all those. So, the list of all the possible answers are going to be 1, 2, 3, 6, 9, 18, 1/3, 2/3, -1, -2, -3, -6, -9, -18, -1/3, and -2/3. And that is my list of all the possibles. Okay? Now, if I was actually trying to find these, this is my list that I could actually put into synthetic and see which one of these gives me a 0 remainder. The ones that give me a 0 remainder would be my zeros. Okay? And before we get farther, let's look. We're going to ask one extra question here. How many zeros are there for this problem? Well, how do I figure that? It's degree. What's its degree? It's 4. This one would have 4. So if all the zeros are real and rational, all 4 of those have to come from this list. And that's why we use the list. Okay? So, how are we going to use this in a real problem? So the real problem is this. We want to actually find the zeros. I don't want the list. I want the actual answers to this problem. I want to know where these guys cross. Okay? So, here's how we're going to do this. The first thing we got to do is we got to find our list of possible. Okay? So my list of possibles are going to be the factors of 3 over the factors of 2. Right? 3 and the 2. So list factors of 3 are going to be 1 and 3. Okay? And their negatives. And then put those over 2. 1/2. 3/2. -1/2. -3/2. So those are all my possibles. Okay? So what we're going to do is now we're going to take this and put it into synthetic, which is going to be a 2, a 3, a -8, and a 3. And our goal is, we're going to bring that 2 down, we got to get this to be a 0. Okay? And we're going to, the numbers we're going to put on the box are going to come from this list. Okay? That possible list. Okay? Now, here's the thing. How many answers am I looking for? What are the how many number of zeros are there? There are 3. Why? Because of my degree. Okay, so I'm looking for 3. Now, the nice thing is, if I can get this down and depress it, when we talk about depressed, I get a depressed equation here. When I get it down to quadratic, I can factor it or put in quadratic formula. Okay? So, we're going to start picking numbers. Well, we're going to pick the easy ones first. Let's start with the whole numbers. Let's plug in 1. If you look at the example in the book, they start with the fractions. I don't know why they start with the fractions. That's kind of silly to me. Start with the whole numbers. Okay, so I'm going to plug 1 in. So we're going to go 2. Okay, put a 2 there. We're going to add. That's a 5. That's a 5. It's going to be -3, -3, and get 0. Hey, there's my 0. So that means 1 is one of my zeros. Okay, so I have 1. How many am I looking for? I'm looking for 3. So I need 2 more. Which means this depressed is going to be quadratic. It's going to be 2x squared plus 5x minus 3. See if it factors or quadratic formula. Now in this case I think it does factor, because I'm going to have an x and an x. Okay, factors of -6, that add up to 5. +6, -1. Put a 2 under that and a 2 under that, which gives me the factors x plus 3 and x minus 1/2. And now this type of factoring really is great. Okay, remember, factors of negative 6 that add up to 5, so positive 6, -1. Put the leading coefficient here, this 2, underneath. The great thing about this is actually going to tell you hold on a second. Something's wrong there. Found the 1. The 1 worked. -6. -3, isn't it? +6. Okay, let me double check where I got this from. I want to make sure I did not copy it down this morning, so I'm going to make sure I'm right. Apple 2. Apple 1. Negative 3. Well, they had a typo in the book. Alright. So, my other zeros, I thought these were my answers, so I didn't make a mistake, but it's actually, they had a typo in the book. So, what makes this one 0 is -3. And what makes this one 0 is 1/2. Okay? And that, folks, is my zeros. Okay? Alright, so the example 2 in the book actually is a pretty long problem. Okay? So, example 2 in the book, I guess I forgot to write it down, is, let's go get it here. Thought I had it written down. Okay? We're going to find all the zeros to the following problem. Oh, I know I was going to do something different, but we're going to do this one instead. X. I'm not going to give you one like this on test because this is way too long. But to give you an idea of what we're going to have is how many solutions are we going to have? How many zeros is that going to be? Make sure I wrote that down right out of the book. Yep. Alright. So, notice we got to find 7 zeros. Okay, why do I have to have 7? Because of the degree, right? So I'm looking for 7. Now, they may not all be real, but we're going to try and find them. Okay? So, little train of thought is, little trick, is there's 7. I need to get this I need to do synthetic all the way down until I can get it down to quadratic. That means I'm going to have to find synthetic 5 times, do synthetic 5 different times, and make it. And we're going to show you how we're going to train it. Okay? Now, what are my list of my possible? Well, remember, that's the factors of 6 over the factors of 1. That's pretty easy. So it's going to be plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. Those are all my possibles. Those are the possible real ones. Okay, now remember, some of them can be used multiple times because if it's used multiple times, it's a double root or a triple root. Okay, so here I have, these are those possibles. There's no fractions here because 1 is my leading coefficient. So what we're going to do is we're going to set this up in synthetic, and a pencil is really better because they're not always going to work nice. But our goal is to bring this first one down and get a 0 here. Okay, and I'm going to start picking from my list. Okay, now to do that, we're going to start with 1. Okay, so I'm looking for my final. Here, this is where I'm going to put my zeros at, and I need 7 of them. So we're going to throw a 1 in. Okay, 1 is going to be a 1. This will be a -1. negative 1, negative 6, negative 6, 0, 0, negative 1, negative 1, 1, 1, 6, 6, 0. So 1 is a 0. Alright? Now, how do we then continue this down so I can get it depressed? Because if I depress this, that's going to be x to the 6. Okay? Because that's constant. X to the first, x to the second, x to the third, x to the fourth, x to the fifth. 6, 5, 4, 3, 2, 1. So, 0, so that's constant. X to the first, second, third, fourth, fifth, sixth. So that's to the 6. Okay? What we're going to do is we're going to do a new synthetic, but below it. And we're going to cut it off right here. Okay, I don't need this 0 here. So I need another one that's going to give me 0. Okay? Now what are we going to put in the box? Well, because you could have double roots or triple roots, okay, don't forget, I need to check 1 again. So we want to check 1 again. Okay? So in case it's a double root. If it's not a double root, then 1's never going to work again. Okay? So we're going to run this through. 0, 0, negative 6, negative 6, negative 6. That's going to be negative 6, negative 7. Negative 7 would give me negative 6. Negative 6 is going to be 0. And look, it's a 1. So it's another 1. Okay? Now, because there's a triple root, whoops, that's a 1. We're going to continue this. We're going to go down again. Okay? Actually, we're going to go to here. Okay? We're going to go to here. Now, technically, we want to check 1 again. If I check 1 again, I'm going to tell you now it's not going to work. I'm working in pen. If I had a pencil, I'd work in pencil. Put 1 again just to see if it's a triple root. Okay? And you plug it in and it will not work. Okay? So, FYI, 1 does not work a third time. Okay? So now 1's done. So now I'm going to try negative 1. Okay? Why do I try negative 1? Because that's the next easy number. I did positive 1, now I'll try negative 1. So I'm going to try negative 1. Okay? So we're going to run that through. 5 would be 5, would be negative 1, would be 1, which would be negative 6, 6, and it does work. So negative 1 does work. Okay? Well, where am I at right now? Well, this is remainder, so that's constant. X, x squared, x cubed, x to the 4th. So I'm still not at quadratic yet. So we need to do it again. Okay? Now, I would check negative 1 again. Okay? I would run negative 1 through and it will not work. Okay? So then I go to 2. I check 2 because that's next on my list. So we try 2, put 2 through, and it doesn't work. So then you would try negative 2. And I know it's tedious, but at least it's quick. Okay? Negative 2, negative 3, that'll be 6, that'll be negative, well, it'll be 1, sorry, which would be negative 2, which would be negative 3, which would be 6, which works. So negative 2 works. Okay? So, I still need one more. We would try negative 2 again. Negative 2 would be negative 2, be negative 5, be 10, which would be 11, which is not going to work. So negative 2 doesn't work again. So then we would try 3. Which put 3 in. That'll be 3. That'll be a 0. That'll be a 0, a 1, a 3, and 3 works. So 3 works. Now I have 5 so far. So I've gotten 5, which means I have 2 left. Which means this depressed equation should be quadratic. X squared plus x is equal to 0. Why? Because this is x squared, this is x, and this is constant. Alright? So I get this. Well, I can use square root method to solve that. So square root method would be move the 1 over and get negative 1 and square root both sides, and I get x is plus or minus the square root of negative 1. What's the square root of negative 1? I. So I get plus or minus I and negative I. And there are my 7 answers. Okay? Now notice 2 of them are non-real. But what I do want you to notice is all of the real ones come from this list. The non-real ones will be imaginary. Okay? So I'm not going to give you one that long. If it starts at x cubed, you only have to find 1 and then use quadratic formula. If it starts at x to the 4th, you find 2 and then you can do quadratic formula. You got to get it down to x squared. Okay? And we just want to do one little reminder. Okay? How do I graph if I know the zeros? Okay, we did this the other day. This would be a single, this would be a single, these would be a double, and that would be a single, correct? So 5 would be at a single, 2 would be at a double, 1 would be at a single, and then negative 1 would be at a single. Okay? Now, how do I find my quadratic, or for my y-intercept? Well, I need to put these in terms of, this would be x plus 1, x minus 1, sorry I did that backwards, x minus 2 squared, and this would be x minus 5. Okay? This is the 1, the negative 1, and the other ones, right? Plug 0 in for all these x's. That would give me 1 times negative 1 times negative 2 squared times a negative 5, which would be, that's 4, negative 1 times 4 times a negative 5, which would be 20. So my y-intercept is at 20. Okay? Now, there's 1, 2, 3, 4, 5, which means this is x to the 5th, and it's going to be positive in front, so it's going to end behavior, starts low, ends high, and so it's going to do something like this. Remember, 2 is a double root, so it bounces, 5, and so you get something that looks like that. Okay? Just kind of wanted to throw that back in, even though this was a long video. Sorry about the length of the video, but hopefully this helps. Okay? If it does ask you to graph, then you can just use your graph calculator if you know the formula. Okay?